Hello everyone. So today we'll be solving another dynamic programming question called longest increasing subsequence. So the question reads as given an integer array nums, return the length of the longest strictly increasing subsequence. Okay, so as you see in the first example, so we have to find the different subsequences and we have to return the length of the subsequence that is longest of all. So now let's see this in whiteboard. So the first example states that we will have an array like 10, then let it be like 9, 2, then we'll have 5, 3, 7, 101 and 18. So what are those subsequence? For example, every number itself is a subsequence of one length, right? But if we pick 10, what is the next value that is greater than 10? That is 101. So the length will be subsequence. If we consider 10, will be 2, or if we consider 18, the max length will be 2. Same way, if you consider 9, it becomes the same because 101 is greater than 9, so length will become 2. If we consider 18, length will become 2. But if we consider 2, the length will become 5 is greater than 2, 7 is greater than 2, then 101 is greater than 2, so length will become 4. If we consider 18, then 2, the length will become 4, and so on. So the max length here is 4, so our result should be 4, right? Now how are you going to calculate this? So we can calculate this in a dynamic programming way from right to left. So we're going to start from the right side and we're going to create a pointer here, let it be I, right? Let's put the indices here like 0, 1, 2, 3, 4, 5, 6 and 7. So we're gonna start, our I will be at 7, then we're gonna create a DP array, and since every value is minimum minimum of substring length is 1, so we'll be initiating the array as 1, right? Then what are you going to do? First we're going to start from 101, because anyway the last one will always stay 1 because there is no item to the right side of 18, right? Let's start our I plus from 101, from 6th index. Then from here we're going to compare, is 18 greater than 101? No, right? Then it's going to stay 1. Now we're going to move our pointer to 5th index, that is value is 7. Now we're going to compare again, is 7 greater than, it's 7 less than 101? Yes, right? So what will be the length of the substring if we consider 101? This is 7 is 1, and for 101 this is we calculated already, that is 1, so total will be 2. 18 is also larger than 7, so if we consider 18, what will be the length? That is 1 plus 1 equals to 2. Then because our question asks us what is the max length, right? So what will be the max of this 2 number? That is 2, so our number here will become 2. In same way, we're going to move our pointer now to 4th index I. Then again we're going to compare everything right side to the I. So now is 7 greater than 3? Answer is yes. So then if we consider 7, what will be the substring length? 1 plus then 2 equals to 3. Same way, if we consider 101, it will become 2. If you consider 18, it will become 2. Then max of these 3 number is 3, right? Same way now we're gonna go to 5. We're gonna move to like our third index, whose value is 5. Now we're gonna see if 3 is greater than 5. No. Is 7 greater than 5? Yes. So what will be the substring length if we consider 7? That is 2 plus 1, that is 3. If you consider 101, that is 2. If you consider 18, that is 2. So max of this 3 number will be 3. Same way now our pointer will go to second index, and then we're going to compare, like, is 5 is greater than 2? Yes. So if you consider 5, what will be the length? 1 plus 3, that is 4. Same way this one is 4, right? If you consider this will become 3. If you consider 101, that is become 2, and if you consider 18, that is become 2, and the max of this whole every number is 4. Same way you're going to calculate that 9. So 1 plus 1, this is 2, then 1 plus 1 or 1, that is 2. And by the way, by the time we coming from right to left, we will be keeping track of the max for every calculated value. So at the max, the result will become 4, right? So this is the concept. For every number of I, we're going to reduce it, and then from that number we're going to compare that number to the every number came before it to the right side. And now let's implement this logic using JavaScript. Okay, then now we're going to first create a variable called result that's going to store our max value result, and we're going to initiate this with 1 because the default the minimum substring length is 1. Then we're going to create the DP array, that is like array with nums dot length with the same length. Then you're going to fill it 1 because the minimum substring length is 1. Then we're going to iterate through all the nums from right to left. So for let I equals to nums dot length minus 2. I'm going to start from minus 2 because the last element anyway will always stay 1 because there is no substring after that, right? Then as long as I greater than equals to 0, I minus minus. Now second, again we're going to iterate, we're going to compare every element to I. So again we're going to run another for loop for let j equals to I plus 1, and this one we're going to run till the length, so j less than nums dot length j plus plus. So now our DP array value will stay 1 if the value the current value is less than the greater than the values to the right. If the current value, ith value, is less than the value to right, we have to pick the DP value and add it, and you're going to store the max, right? We're going to compare every element and you're going to store the max. So what you're going to write here is if nums of I is less than nums of j, then our DP of I equals to math dot max we're gonna DP of I and then dp of j plus 1, right? So the dp will be updated with the max for that particular value. At the same time, we have to track the max with the result, and you're going to do that using result equals to math.max now do the same result and dp of I. And at the end, we're gonna return the result. So this should solve our question. Let's see our test cases. So I see the test cases are already passing. Let's run them again. So all of our test cases has passed, and that's that. Thank you.